Hey there, and welcome. Ever stop to think about how your computer talks to your printer, or how your phone seamlessly streams video to your TV right there in the living room? Well, it's all thanks to a real unsung hero of the networking world, the data link layer. And today, we're going to pull back the curtain and see exactly how it works. So let's start with a puzzle. You know you have an IP address, right? That's your ticket to the entire internet, connecting you to servers all over the globe. But what about your Wi-Fi router? The one that's literally just a few feet away from you right now. What's the address for that? Super short, one-hop trip. And the answer is Layer 2, the data link layer. This is the part of the network stack that handles all that local chatter. See, it doesn't care about the final destination halfway across the world. Its entire job, its whole reason for being, is just to get a message from one device's network card to another, as long as they're on the same local network. To really wrap your head around this, let's use an analogy. I want you to think of the data link layer as your friendly neighborhood mail carrier. This mail carrier doesn't handle international shipping or even cross-country packages. Nope. Their job is to make sure a letter gets from your house to the one right down the street. That's it. Simple, reliable, local delivery. Now, our mail carrier here actually has two different jobs, two sublayers. First, you've got the Logical Link Control, or LLC. Think of that as the front office manager. It takes the letter, the data, from the software layers above it. Then you've got the Media Access Control, or MAC. This is the carrier on the street, the one who actually puts that letter in a proper envelope, addresses it, and makes sure it gets delivered. And this really gets to the heart of it. The data link layer isn't some abstract, cloud-based concept. It is all about the physical communication between the actual network interface card, that little chip in your laptop, and the network interface card in your router, or your printer, or whatever else is on your local network. It's as fundamental as it gets. Okay, so for our mail carrier to do their job, they need a couple of things. First, they need a map of the neighborhood, and second, they need some clear rules for driving on the roads. Let's look at how all this local traffic actually flows. First up, the map. Now, there are two kinds of maps here. You've got the physical topology, that's how all the devices are literally wired together. You can think of these as all the possible roads in a city. But then you have the logical topology. This is the path the data actually takes. It's the specific route the mail carrier follows, which might not use every single road. And at the end of the day, it's that logical path, that mail route, that really matters. All right, what about the communication rules? Well, devices can talk in two ways. There's half duplex, which is exactly like a walkie-talkie. You push to talk, then you let go to listen. Only one person can talk at a time. Then there's full duplex, which is like a modern phone call, where you can both talk and listen at the exact same time. As you can imagine, most modern networks, especially wired ones, absolutely love full duplex. And finally, how do we decide who gets to talk and when? Well, on a contention-based network, think Wi-Fi, it's kind of like a free-for-all. Devices basically listen to see if the line is clear, and if it is, they start talking. If two talk at once, you get a collision. So they both stop, wait a random amount of time, and try again. On the other hand, controlled access is much more polite. Every device gets a scheduled turn to speak. It might be a little slower, but it's way more orderly. Okay, so we've got our mail carrier, we have a map, and we have the rules of the road. But what is our carrier actually delivering? What's inside that mailbag? Well, they are delivering a very special kind of digital envelope. It's called a frame, and it's the package Layer 2 uses for, well, everything. If you break it down, a frame is pretty simple. It's got three main parts. There's a header at the front, which has all the addressing info. Then there's the data itself. That's the actual letter, the packet from the layers above. And finally, there's a trailer at the very end to wrap it all up. So you've got the address, the letter, and the seal on the envelope. But this digital envelope is incredibly well organized. You've got start and stop fields that say, hey, the message starts here and ends here. You've got the addressing field with the local to and from MAC addresses. The type field tells the receiving device what kind of data is inside, like, hey, this is an IPv4 packet. And then in the trailer, you have the really cool part, error detection. This is a little calculation that lets the receiver check if the message arrived perfectly or if it got a little scrambled along the way. And let's be absolutely crystal clear about that address. The Layer 2 address, the MAC address, is strictly for local delivery only. Its only purpose is to get the frame from one device to the very next device in the chain. It is not the final destination IP address. Every single time your data hops to a new router on a new network, that Layer 2 address gets thrown away and a new one is created. And this brings us to what your router does all day, every day. It basically acts like a postal sorting office. First, it accepts a frame, that envelope, from your computer. Then it de-encapsulates it, which is just a fancy way of saying it opens the envelope, it looks at the packet inside to figure out the final IP destination. Then it re-encapsulates it, puts that same packet into a brand new envelope with a new local address for the next leg of the journey, and sends it on its way. This exact process happens at every single router between you and your destination. So when you pull the camera back and look at the big picture, you start to see just how unbelievably important Layer 2 is. The entire global internet, this massive, complex system, literally could not work without this simple, reliable, hop-by-hop local delivery system. You know, every epic journey is just a series of small steps. And in networking, Layer 2 is responsible for every single one of those steps. So, to sum it all up, what are the big things to remember? Layer 2 gets data ready for the physical network. It's all about that direct communication between network cards. It packages everything up neatly into frames, and it uses those physical MAC addresses for local delivery only. And on top of all that, it follows the map laid out by the topology and the rules of the road set by the access method. And that leaves us with one final thought to chew on. The data for this explainer you're watching right now traveled from a server, probably through a dozen, maybe even more, different routers to get to you. And at every single one of those hops, it was unwrapped from an old frame and put into a brand new one. So how many of those tiny local mail deliveries had to happen absolutely perfectly just for you to watch this? Pretty amazing when you think about it.